So today we're going to talk about fan controls. You don't see these guys very often on equipment anymore as they're old school on old furnaces, but it's a fan control. So a fan control controls cut out, cut in, and high limit for your furnace on an older furnace. So on this side, you're going to see this spiral bimetal strip here. And this guy actually, as it heats up, it has two dissimilar metals, and it's going to spin when it heats up. And it's this part of this is going to be mounted very close to your heat exchanger. So it's going to be screwed in, and this half is going to be inserted by your heat exchanger. If you ever replace these, you need to make sure it's the exact same length, because if it's shorter, you might not be reading temperature in the optimal designed area. If it's longer, the same thing. So that's very important. So this bimetal strip here, or spiral, when it heats up, it will twist. And what is it twisting exactly? See this metal guy here, see how I'm twisting it? When it heats up, it's actually going to twist. And there are these little kind of hands here, and you're going to adjust these hands for cut out, cut in, and high limit. You'll have the ports here for connecting your wires for going to the gas valve, through the high limit to your gas valve and to your blower. This tab here is to go from your blower fan from auto to on. So they also call it auto and summer mode, depending on the manual. So the first arm here, if you were to adjust this, this would be your cutout set point. So usually I like to set my cutouts to around 90 degrees Fahrenheit. Then you're going to set your cut-in set point. So this is when your heat turns on and your heat exchanger is building heat. There's going to be a delay, a temperature delay. And when it hits that temperature, it's going to engage your furnace fan. So you need to make sure the gap between your cutout and cut-in isn't too small, or your fan will short cycle. So I usually set these around 130 or so, personally, and that's where I like it. So once the heat exchanger warms, it's going to spin this dial. It's going to hit near the arrow here, and when it hits, it's going to energize the blower. Okay? And let's say there was an issue. So we had a faulty blower motor. So now it's going to turn, energizing the blower, but the blower might not actually energize. So what would happen is the temperature in the heat exchanger, where this bimetal strip is reading, is going to keep increasing because we can't cool the heat exchanger because the blower's not working. So this strip would get hotter and hotter, and the thermal expansion would go up, and it would turn the spiral, which then turns this head, and it's going to keep twisting until it hits the third arm here. So that third arm is actually for the high limit. So in our area, most people like to set the high limits around 180. Oh, this one's a little stiff. But people like to set the high limits around 180, so right there. So if this dial was to spin and hit that 100, hear that click? Hit that 180 set point, it's actually going to open the contacts and turn power off to the gas valve as a safety. So once again, a fan control controls the blower, and it also controls voltage flowing to the gas valve. It acts as a high limit. So you need to set the cutout first, cut in, and then high limit. So how the cutout works is now we've hit temperature, so the gas valve turns off. We're good with that? Room temperature rose, we hit temperature, gas valve turns off. And now the blower will be cooling this bimetal strip and also the heat exchanger. And as it cools, it's going to keep turning. And once it cools to our cut-out set point, which we set at roughly 90 degrees Fahrenheit, we said, it will de-energize the blower motor, and the unit will go into standby. So it's really important to don't set the cutout too high, because if you do, then your heat exchanger is going to be very warm still, and you're actually going to waste energy. So we want to try to remove as much of the heat of the heat exchanger to get that last little bit of heat into the space instead of wasting it, in my opinion. So yeah, it's the basics of a fan control.